Hello, everyone. First of all, I would like a quick check from all of you. Is my voice audible to all of you? Can I just have a yes or no in the chat box?
Yes.
Okay, great. Thank you so much. Yes, I welcome you all to our today's webinar on Readiness and Liveness Probes in Kubernetes. So WizLabs is hosting this webinar in collaboration with Opstri Solutions, which is a highly specialized cloud and DevSecOps engineering company. And it has expertise in making a highly productive application delivery. Now, I would like to introduce you all to our panelists for the day, starting with the speaker, Abhishek Dubey. Hi, Abhishek. Thank you for getting on board for this webinar.
Okay. Hey, everyone. I think my video is off. Sneha, can you turn it on?
Let me check.
Yeah. Hello, everyone.
So introducing Abhishek to all of you. He is a technology enthusiast with 5+ years of experience in working with the latest DevSecOps tools and practices. Currently, he is working with Opstri Solutions as a senior DevOps consultant. So, and then we have Mayank and Abhishek Maurya also with us. So we have two Abhisheks with us. Don't get confused. So Abhishek Maurya and Mayank, they are from the WizLabs team and they are a part of the products team with us. So thank you all for joining us as panelists. Over to you, Abhishek. Abhishek.
Thank you so much, Sneha. Thanks for the context setting. Let me start sharing my screen. Okay, let me confirm with everyone. Are you guys able to see my screen? If yes, can you please respond in chat box?
Yes, Abhishek, it is visible.
Okay. Great. So, hi everyone, welcome to the webinar. Today we are going to discuss the topic Readiness and Liveness Probe inside the Kubernetes. As we know that Kubernetes is a very vast technologies, and nowadays a lot of companies are moving towards the cloud native architecture and they are introducing containers in their modern technology. So to manage those containers, they need an orchestration engine. A lot of people use different types of orchestration engine like Kubernetes, ECS, OpenShift. But Kubernetes is more like catching technology nowadays and people are using extensively. So since Kubernetes is a very vast technology, so we picked a very specific topic inside the Kubernetes, which is the Readiness and Liveness Probes, which is more similar to managing the application lifecycle using the health checks. So we are going to discuss about that. So here I am. As like Sneha already introduced me, but I will also give a little bit of introduction about me. So hello everyone, my name is Abhishek Dubey. I'm working as a senior DevOps consultant at Opstri Solution. I wear multiple hats. I do DevOps training, I do DevOps webinars, and I'm a developer as well. So I work on multiple open source projects, like I'm working right now on Kubernetes, operator framework. I'm a developer in Prometheus as well, and I'm contributing a lot of things inside the cloud native architectures. So that's pretty much about me. Now let's talk about the agenda for this particular webinar. So we will start with the basic question: what are the probes and why they are important? So basically here we are going to discuss like what are the probes inside the Kubernetes and why they are so important. So like why you should use the probes inside the Kubernetes. Then we will move towards the readiness probe concept, where we will discuss about when an application should receive a traffic. So in the readiness probe, we will discuss like if the application is ready to receive the traffic or not, and how does readiness probe work inside the Kubernetes. So we will go through the concept of the readiness probe. Then we will discuss about the liveness probe, where we will check that if the application is live or not inside the Kubernetes cluster, and if it is live, it is responding or not. On the basis of that, what action should liveness probe should perform. So we will discuss the depth concept of the liveness probe as well. Then inside the readiness and liveness probe, there could be a different types of health check handlers we can define. So we will discuss about the type of probes handler inside the Kubernetes, in which we will discuss like what are the different types of handlers we can define inside the liveness and readiness probe for the health check part. And the last part we will discuss, which is the most important. Nowadays, the companies are using a lot of deployment strategies, not inside the Kubernetes as well, a lot in outside Kubernetes environment or outside container environment as well. For example, people are using the rolling deployment, people are using the blue-green deployment. So here we will be discussing about the importance of probe importance of health check inside the deployment strategies. What will happen if we don't define the probes inside an application and do the deployment without it? And what are the consequences? I guess we are pretty much clear on the agenda side. Okay, cool. I'm using that. Okay, let's start with the probes concept. So basically, before starting with the probes, I would like to ask you guys to answer me this. So for example, what do we exactly mean by health check? Can someone respond in the chat box if possible? Okay, pod is alive or not? That's correct. If the application is available, that is also correct. Checking the health of an application, right? Exactly. So there are two things. One thing is the application process is running. The second thing is that the application is actually doing that logic which it is designed to do. So for example, an application process could be running, but it should not be acting anything because it has some dependency and that dependency is not fulfilling up. In that case, the actual business logic of that application is not working. So what we are doing here when we are talking about the probes, in the probes we are talking about the process of checking of health of a Kubernetes based application, container or pod to actually see if it is working fine or not. So that health check, actually we call it probes inside the Kubernetes. And that probes is actually designed to monitor the responsiveness and the readiness of application. So that, for example, if that application is ready to serve the traffic or not, or if the application is already live, is it live or not? So for example, if application is in a deadlock state, it should be restarted. These kind of thing we can achieve using the probes inside the Kubernetes. Now, what are the probes? So basically, if I take a general scenario, in that general scenario, the application could have two types of failure. In a container native environment or a non-container in native environments, the application could have two types of failure. One thing is that we have deployed the application is starting up. In that case, when the application is starting up, it is not ready to serve the request. First thing is that. But if we still send the traffic to that application, which is still in the initializing phase, that traffic will completely fail. So first thing is that could be one application failure when the application is initializing. Ideally, we should not send the traffic to that kind of application. The second thing is that, let's suppose our application is not crashed. The process is completely running fine, but there could be some scenarios that it has some deadlocks. Deadlock could be the kind of scenario where the database connection is not working, or the application process is still running, but the database connection is not working. So whenever you send the traffic to that application, it will not process any kind of request and it will stop responding. So one thing is that when we have deployed a new set of application, the initializing phase, in the initialization phase, we cannot send the traffic because the application is not fully initialized. The second scenario could be the application is already live, but because of some consequences, the application process is still running, but it's not ready to serve the traffic because of some dependency. So in that case, what we should do, we can restart that application. So Kubernetes resolve these kind of problems using the concept of probes. Now, this is the life cycle of a container inside a Kubernetes pod. So basically, here we are talking about a container state. So whenever we create a container inside a Kubernetes, this is a general state. So first stage is that the creation of that particular container inside the Kubernetes pod. Then the state could be running. The state could be running when the process is actually running. And let's suppose if that process has been stopped, it will be in the pause state. Or if that process has been killed, it will simply go into the stop state, and then the deletion stage when actually the container is being deleted inside the pod. So these are the different life cycle of a container inside the pod. Creation of it, running of it, if the container is being paused or stopped, or it is getting deleted. Now, this is a picture which we have created, why probes are important. So let's suppose there's a container which we are calling a pod A. Actually, it should be pod B. So let's suppose this is a pod A, which is an application which we are running here. And here we can see the container state is running. That means the application process is running, but the app is not started yet. Let's suppose it's doing a database initialization. It is populating something. It is doing a migration inside the database, but the process is running. So if we think on the basis of if the process is running, should we send the traffic to that application? Can someone answer me this question? Can we decide on the process running part? If the process is running, are we ready to send the traffic to that application, or there could be some certain checks we should place? Okay, a lot of people are asking. Maybe HTTP health check, yeah. Correct. So basically, if an application process is running, but if it is an initialization process, we cannot send the traffic to that application. Let's suppose it's still making the database connection. So the state of that process is running, but actually that application is not responding. So if we send any kind of traffic to that application will fail. So if you check here, this is the thing which we have defined inside the Kubernetes. So we have defined a readiness probe where we are actually checking if that application process is up or not. So let's suppose if the readiness probe is failed, that means the application is not yet healthy. That means the process is running, but still it's not ready to serve the request. What will Kubernetes will do? The Kubernetes will not send the traffic to that kind of application. But in the right side, if you see this picture, there's a liveness probe in the success state and there is the readiness probe in the success state. In that case, the pod status is running in terms of container and the application. That means the application initialization has been completed and it's ready to serve the traffic. So on the basis of that, Kubelet decides that if the pod or the container is ready to serve the traffic or not. So for example, in the left side of the picture, you can see there's a pod in the red state, and then in the right side, you can see the pod is in the green state. That means the kubelet will only send the traffic to the green state pod because the liveness and readiness has been successfully passed. But on the left side, the liveness has not been checked because the readiness has not been passed. Because of that, the kubelet, the Kubernetes will not send the traffic to it. Now, here are some pointers which we have created for the probes, importance of probes. So in a distributed application setup, basically, if we talk about when we have a microservice era, there are a lot of application. In those lots of application, maybe after some time, there will be some chances that an application is dependent on some other application. And if that dependent application is not working, because of that, your main application will not work. In that case, you cannot go and debug each kind of an application. You need a certain kind of activity where you can say, if the dependent application is not working and you are not able to make a connection, what you can do, you can restart your process and try to make that connection again. The same philosophy will go for the other dependent applications as well. So for example, if there is a dependent application and there is a nested dependent application, where we can say that if you're not able to make a live connection, you should restart your process and try it again. So that is one of the things why probes are important. The second thing is that let's suppose we have a newly onboarded application. The newly onboarded application is more likely, which is onboarding inside the Kubernetes cluster. And while onboarding, there will be the process initialization task where the process is actually started, but still doing some pre-checks or other kind of operations like database initialization, etc., so that it can serve the request. In that particular time period, when the application is doing the initialization, it's not ready to serve the request. So it does not make sense to send the traffic to that kind of application. So these kind of scenarios, the probes are important, which can identify this application is in the initialization phase and I should not send the traffic to this kind of application. Okay. Now the probes are the can be defined on the container basis. So basically, you guys agree with me that pod is the smallest unit inside the Kubernetes, right? Exactly. So no, container is not the smallest. So container is something we cannot create the container directly creating the pod. So Gopala, basically, if you have to create a container, you have to go with the pod level. So basically, we cannot define the probes on the pod level because let's suppose I have two types of different containers running inside a pod. The health check could be different. That's why the probes philosophy work on the container basis. For each kind of container, there could be a different kind of health check. For example, there is an proxy application which is running on 8080 port, and there's a main application which is running on 80 port. Now, those both applications are running on two different ports. And if I define a global level probe, in that case, the probe will never succeed because I have defined at the global level and the condition will not match. In that case, the Kubernetes suggests to define the probes on the level of containers. So for example, for the proxy pod, I will define a probe for 8080 port. And for the main application, I will define the probe on 80 port. So in that case, what will happen? The health check will be two different kind of thing. And if the proxy pod has not been passed as a probe, that container will only get restart, not the complete pod. So that's a very important thing, because let's suppose if I'm running 2 pods and the probe has been defined on the pod level, it will restart the complete pod. And if let's suppose from the out of 3 pod, 1 pod was unhealthy, it does not make sense to restart the complete pod. Ideally, that container should only get restarted, which is not responding at all. So that's why the probes concept has only has been defined on the container basis, not on the pod basis. The fourth point is that probe can easily identify if the container is dead or alive. So for example, let's suppose if an application is running and that application is dependent on some other application, and that other application is not responding, and because of that you have created an health handler in your application. So whenever the dependent application does not respond, what exactly it happens on the health handler, it responds that the dependent application is not healthy and I'm not ready to serve the request. So probe can easily identify that this application is ready to serve the request or not, and if it needs to restart it. So for example, if the application process is running and it's in the deadlock state because of some dependent application, that means if the process is still running, the traffic will not be served successfully. In that case, ideally it should make the connection again. For making the connection again, there are two kind of things. One thing is that you can write the application logic. The other thing is that you can simply restart the process, which we generally do in the DevOps world. So what we can do using the probes, we can simply define if the application is not responding, and if the application is not healthy, you can simply restart my container to make the initialization again and check if it is completely healthy or not. So that kind of powerful feature probes added inside the in the Kubernetes. Okay. Now we have this readiness probe. So basically, here I have added on this picture. Inside this readiness probe, you can check one pod is completely healthy. Let's suppose I am trying to scale up another pod. In that pod, there's a container which is loading. So what will happen? The readiness will try to make the connection with this pod unless and until its health check is passing. In the meantime, the service is giving you orange sign. That means the traffic is not being sent to this pod. The traffic is only being sent to the ready pod. Once this is ready 100%, then only the traffic will be served to this particular pod. So for example, when it's in the loading state, the traffic will only serve the ready pod. And once it becomes the ready, the both becomes green and the service will send the traffic to both of the pods. So what exactly Kubernetes does, the Kubernetes uses this readiness probe concept to identify if the application is ready to serve the request. Because there are a lot of things we actually do when the application is in the initialization phase. For example, your application has started. And once that application has started, it has to do a lot of things. It has to connect with the Redis, it has to connect with the MySQL database. And while making that connection, it has to initialize some inventory inside the database as well, or you can say in the caching mechanism. While making those initialization, you cannot agree upon that I am ready to serve the request because your initialization is not completed yet. You are only ready to serve those requests once those initializations are completely successful. In that case, what should ideally be happen? When the initialization phase is happening, the Kubernetes service should not send the traffic to that pod which is making an initialization. So that's what we are showing in this picture as well. So for example, in the ready state, you can see the traffic is being sent to the ready pod continuously. But if there is another scale of pod, let's suppose I have changed the replica count to 2, another pod has been scaled up. It will wait to initialization to be completed. That means it will wait for the readiness probe to be passed. Once the readiness probe has been passed, then only the service will send the traffic to the other pod as well. So that's a powerful feature of readiness probe where we can determine that if my application is actually ready to serve the traffic or not. Does it make sense, guys? Cool. Okay. Then we have this Liveness Probe concept as well. So inside this, we are actually checking if the container process is still executing. That is completely fine. But what if that application is the application process is running, but it's not ready to serve the traffic, which we have already discussed. Let's suppose I have 2 pods, and from the 2 pods, one pod is actually serving the traffic. The other pod somehow get into the deadlock state. Let's suppose it's not able to connect with the dependent application. but this pod is able to connect with a dependent application. Now, if someone is making a request to the Kubernetes service, some of the requests will succeed because it's going to the green pod, but some of them will fail because it's going to the red pod. That means that this pod is actually in the hung state, but the process is running and Kubernetes is not able to identify if it is in the hung state or not. So if we do not define the liveness probe, what will happen? Some of the user will get a success response and some of the user will get a failure response. So what we can do here, we can define in the liveness probe that you should check my application liveness as well, that my application process is running, but is it fulfilling the business need or not? So for example, if the application process is running and the dependent application is not running, that means it is not able to connect with the dependent application. That means this application cannot serve the traffic. In that case, I would probably like to make a connection again. In that case, I want to restart my container. So what we can do here in the liveness probe, we can simply say that I have defined a liveness probe. If that particular handler is not getting succeed, that means if I'm not getting a healthy health check from this particular pod, I will simply restart the container so that it can make the connection again. So if you see here in this picture, we are doing the same thing. For example, the liveness probe has been failed because the pod was in the hung state. So the pod has been restarted again and it's in the green state again. So that's a powerful feature of the liveness probe, which can enable the auto healing feature of Kubernetes. When we say that Kubernetes has an auto healing feature, that's what we are talking about here. So for example, if my application is not responding, Kubernetes can automatically restart that application so it can start working again. Does this make sense, guys? Okay. I think a few people have. Cool. I'll move ahead then. Now we are talking about the types of probes we have inside the Kubernetes cluster. So when we are talking about the types of probe inside the Kubernetes cluster, we have different types of probe. So let's talk about the command probe. So basically, we have like 3 types of probe inside the Kubernetes cluster where we can define. One is the command probe, second is the HTTP probe, and third one is the TCP IP probe. So the HTTP probe is a kind of a probe which we actually define for an HTTP layer 7 based application, where what we do, we define a port number and along with the URL. So for example, I define a port number, like I want to make a request on 80 port on /health URL. And if I'm getting a 200 status code, that means that is a healthy status code and you can pass the probe. But if I'm not getting a 200 status codes, let's suppose I'm getting like 502 or 404, that kind of status code means my application is not responding and it needs to be restarted again, or it's not ready to serve the traffic. So on the basis of status code in the HTTP probe, we can define that my application is ready to serve the traffic or it needs a restart. So the HTTP probe is more about for the layer 7 based application, where we define a port number along with a URL, where it make a request and check the status code, that if the status code is valid or not. Similarly, we have a TCP IP based probe. Inside this, I guess a lot of guys have used this telnet. For example, if every time you have to make a network connectivity test, you guys use the telnet to make a connection. For example, if the SSH is working fine or not, you do a telnet on 22 port. The TCP IP probe is similar kind of thing. What exactly it does, it actually checks if the port is listening or not. You can think it will not check if that port, after that the process is running or not, or after that there's a database error or something like that. It will only check the port is listening or not. So for example, if you have a layer 4 based application, for example, you have a MySQL, you have a MongoDB, there you don't have the layer 7 based capability. You cannot make an HTTP request to MySQL, MongoDB, or Redis based applications or Redis based databases. In that case, you need a mechanism through which you can actually check the port which we have defined for this databases. For example, for MySQL, we have defined 3306, if it is actually listening or not. So we will do a telnet and check that the 3306 is listening or not. The same kind of thing we can do using the TCP IP probe, which will make a connection and it will only check if the 3306 port is running or not. The last one is the command probe. Now, here I'll take a pause. So basically, I have defined the HTTP probe and I have defined the TCP probe. So basically, can someone answer me this? What kind of use case for could be for the command probe? Anyone? Okay, init container. systemctl commands. Okay, let me put it this way. For example, you are deploying a MySQL based application inside the Kubernetes cluster, and that MySQL has been deployed inside the Kubernetes cluster. Now, what only 3306 port checking will be sufficient, or you would like to check something else as well? So how will you do the database sanity? For example, you make a connection on 3306, somehow it's successful. Is it sufficient? Yeah, MySQL, I'm taking the same example of MySQL. Here I'm talking about, for example, select query, running query, writing application logic. That's correct. So for example, let's suppose I have deployed the MySQL inside the Kubernetes cluster as well. But after deployment of the MySQL, the 330 check is passing, but my application is still not responding because some of the table and some of the database are still missing. In that case, the TCP IP will not be sufficient to check that kind of scenarios. For that kind of scenarios, you can use the command probe where you can write a shell script or a shell logic where you can simply say that I want to execute a MySQL command. And on the MySQL command, I would like to check if this database exists or not, or if this particular table exists or not. And on the basis of that, you can give an exit code. So for example, as we know, inside the Linux or any other operating system, when we get an exit code of 0, that means it's a success, or any other exit code means failure. So the liveness or in the command probe, it will only check for the exit code. So for example, if the exit code is 0, that means it will assume that the command probe has been successfully passed. And if the exit code is not 0, that means it has been failed. So what kind of logic I can define in my command? I can write a shell logic where I can say that I will check a database, I will check a table. If this database and if this table exists, I will give an exit code of 0. That means my command probe has been passed. But let's suppose if that database or table does not exist, I will simply say that my exit code is 1. On the basis of that, the probe will identify that my that database is not completely healthy and it is not ready to serve the traffic. So that kind of intelligent logic we can write inside the command probe. Does that make sense, guys? You guys can respond on chat. Okay, cool. Awesome. Now, here I have defined a little bit of example of the probes. So for example, I have an exec probe. Inside this exec probe, I have given an example of a command. So inside the command, you can see that I have written a shell command where I'm actually doing a cat temp healthy file. So for example, it will try to read this temp healthy file. And let's suppose in the temp healthy file, if this file exists, what status code I will get? You guys can answer on chat. Okay, and if this file does not exist, what type of exit code I will receive? 1. That's completely correct. So basically, what is this command probe is doing? It is checking if this file exists or not. So while cat command, it is checking if this file exists, I will give an exit code of 0. If this file does not exist, I will give an exit code of 1. That means this command probe has been failed. And if it is 0, that means this command probe has been passed. The other parameters we will talk about in the further slides, but this is how you can define a command probe inside the readiness and the liveness. Similarly, we have an HTTP probe. So inside this HTTP probe, we can define, I have defined like my path is health and my port is 8080. And there are some custom headers I would like to pass, like my custom header name is custom header and the value is awesome. So for example, what it will do, it will make an HTTP request to this URL on this port by keeping this header. And after that, it will expect a valid status code. Let's suppose if I'm getting a valid status code like 200, or in that case, we can simply say that my application is completely healthy. But if I'm not getting a status code of 200, that means I'm getting 404 or 543. That means my application is not healthy and not ready to serve the traffic. On the basis of that, the HTTP probe handler will completely fail. And if it is getting a valid status code like 200 on this port with this URL and with this headers, it will simply say the HTTP probe has been passed. And the last thing is the TCP socket, which we have already talked about, like checking a telnet command. So basically here we are just defining a port number 8080. So what it will do, it will make a telnet, it will make a connection with the 8080 port and check if it is listening or not. Let's suppose if it is giving a connection refused. For example, somehow the MySQL process is not running completely and 3306 port is not responding at all. In that case, it will say that the 3306 has been given a connection refused error. So I will simply restart the container. And if it is able to listen on that port, for example, it is able to make a connection to that port, that is sufficient for a TCP socket to be passed. And it will say that I'm completely healthy. I will pass your probe health check. Does this make sense, guys? Okay, awesome. Let's move ahead with the probe parameters, which we are going to talk about. So inside the probe parameters, we have a parameter called initial delay second. So the initial delay seconds, which you have seen here, the initial delay seconds is the time for executing this for the first time. So for example, my application process is initializing. That means I will not execute the probe directly. I will wait for some time before executing my probe as well. So the initial delay seconds is exactly that. So for example, I know that my 8080 port takes like 2 to 3 seconds to come up. So I can say that wait for 3 seconds before executing my probe on 8080 port. So the initial delay seconds is more likely the number of seconds we define for the liveness or readiness probe, which will be executed against the container. So it will take that much of delay time. And after that, it will make a request to the particular container. Then we have a period seconds. So after making this request, in how much interval I want to make a readiness or liveness probe check. For example, let's take an example of liveness probe. So inside the liveness probe, my application is running. At every 5 seconds, I'm checking my application is running or not. So for example, if you see here, I have defined an HTTP handler where I'm defining the path on health, port is 8080, and the headers are these. After that, I'm defining the period second equals to 3. That means at every 3 seconds, it will make a request to this health port, and it will check if I'm getting a valid status code or not. If it is not getting a valid status code, that means it will fail that probe. So here we can define the time interval on which we want to make a request to this particular URL. But we should never keep it too low, because that will create unnecessary load on the application as well. So generally people keep it like 5 seconds, 10 seconds, in some cases 3 seconds as well. Okay, now the next thing is the timeout seconds. The timeout seconds is the more likely the value which we define here. For example, let's suppose we are making a connection to this 8080 port and the connection is there, but I know that my application take 1 to 2 seconds to answer my call. In that case, if I am not defining the timeout seconds by default, let's suppose it takes timeout takes one second and my application take 2 seconds to respond. In that case, my probe will always fail. So we can configure the timeout as well, where we can say that at this particular time you can try, and if in this particular time you're not getting the response, then you can give the timeout. So for example, if I have given that 10 seconds of timeout, it will make a connection to health port on the health path on 8080 port, and it will wait for 10 seconds for that health check to be passed. And if in the 10 seconds I'm not getting the response, it will fail that probe. But within the 10 seconds, if I'm getting that response, it will simply say that your probe has been passed. So we can define the custom value for timeout, for example, whatever the thing we want to define. So for example, similarly on the 8080 port as well, let's suppose when I'm making a connection on 8080 port, that 8080 port is responding in 5 seconds. So I can simply say that I want to make a timeout to 6 seconds. And within the 6 seconds, if it is responding, that means the probe is passed. And if it is not giving a response within the 6 seconds, that means the probe has been failed. So we can define a custom value using the timeout. Then we have a success threshold. So basically, let's suppose if I'm making a connection to a probe, for the first time, it has been successful, but for the second time, it has not been. So here we can define the success thresholds as well. So for example, let's suppose I have defined the success threshold 5. So what it will do, it will make a 5 consecutive hits on my health port and check if all those 5 requests are successful. After that, it will pass that probe. Otherwise, it will fail that probe. Similarly, we have a failure threshold as well. So the failure threshold is vice versa of success threshold, where it will check how many failure I should get before restarting my application. So for example, let's suppose my one probe has been failed, but that does not mean I should restart my application. That could be some different kind of issue. So I'm saying that at least 5 probes should be failed, 5 consecutive hits to my health port, on the health port, on the health URL, if those are failing, then only you can restart the application. So that will happen here. So what it will do, it will make 5 consecutive hits to the health URL on 8080 port. And if it is getting failed each and every time, it will restart the application. Similarly, on the success, if I'm defining the 5 as a value of the success threshold, if it is making a 5 consecutive request to the health URL on 8080 port, and if it is getting the status code of 200 every time, that means my application is ready, and it will mark it as ready, and the Kubernetes service will start sending the traffic to it. Now, here I'll take a pause, and I will ask you guys, is this clear? Okay, I got 2-3 response. So here I will like to give a little hands-on session on this as well, so that people can have a better clarity on how to use Readiness and Liveness Probe. So I created one lab which is public. I'll share with you guys as well. You can try it out by yourself as well. But here I will like to present that. Is it good? Awesome.
Sorry to interrupt you.
Yeah,
so
sure.
we have 2 questions in the Q&A section.
Okay, let me
check them out. Yes.
Okay, if the Readiness Probe fail, will the pods keep spinning new instances until it goes out of control? No, it will not actually spin the new instances. It will simply restart that again and again. Onion. Does that answer your question? Okay, I'm assuming yes, if he's in the call. Okay, yes, Tagar has a question that how does KTS automatically restart the pod? Okay, how does KTS automatically restart the pod in the Liveness Probe? It will not restart the complete pod, Yash. So it will restart the container, just like I was discussing that, for example, in the probe, you can have multiple containers. So it does not make sense to restart all the containers if one of the containers is failing. So we define the Liveness and Readiness Probe on the basis of container. So for example, if I have defined this kind of probe here, if I go to the previous slide, if I define this kind of probe where I'm saying I will make a request on the health port on the 8080 port, and if this does not respond for this particular container, that means this container will be restarted only. So the complete pod will never get restarted. A particular container will get restarted. Does that answer your question? Yes. Okay, cool. Okay, next question is, I will dismiss this. So all the pods restart VR because of Liveness Probe? No, ish. So basically pod restart from the Readiness Probe as well. For example, the Readiness Probe we are defining here where we are saying that application is ready to serve the traffic or not. So for example, if the pod is creating for the first time, in that case, the Readiness Probe will come into the picture, which will see if the pod is ready to serve the traffic or not. If the pod consecutive health checks are failing inside the Readiness Probe, it will restart in that case as well. The Liveness Probe is more about the pod is ready now. It is serving the traffic, but is it healthy throughout the time? For example, the pod is ready now. After 5 minutes or 10 minutes, it could happen that it is not responding. In that case, I need a mechanism through which I can see if this pod is live to serve the traffic or not. So there the Liveness Probe will come into the picture where it will check the liveness of application. The application is actually responding or not. So these two are completely different things. So the restart happens in Readiness Probe as well and the Liveness Probe as well. But the Readiness Probe have the concept of while the pod has been created for the first time, then it will execute the health check. The Liveness Probe can took it from there after the application is live. Is it still live? That's the feature of Liveness Probe. Does that answer your question, Ish? Okay. Awesome. Can we set to run these probes in timely manner to keep checking the health randomly? I did not got your question, Viraj. Can you please elaborate what exactly you are asking? You need, so Gopala, you need the failure threshold in the readiness probe and the liveness probe both. But for example, in the readiness probe as well, there could be one scenario where you can get one failure threshold, but after that you are getting the success threshold. So the failure threshold can be defined in the liveness probe as well, in the readiness probe as well.
Abhishek, can you hear me? This is Virija.
Sorry, this is
Virija. I just asked you a question on the can we run multiple times. So my question is, the probe has run and it is successful in the initial startup of the container or the pod. So after 30 minutes, again, I want the probe to run to check its health that time. After 30 minutes, how it is.
Yeah, so you can define the period seconds here. That's what it is. If you remember, we were talking about
okay.
This. Yeah. Here you can define the time in the seconds. So you can say 16 to 30, 180 seconds.
So after this time, again, it will run the probe and check.
Exactly.
Okay, thank you.
1800 seconds. Okay. Now you have this another question we have, Onion. Instead of using the kubectl, you can just use the plain bash to check the health status. So kubectl is Onion to apply the configuration. The health status is on the basis of these handlers which we have discussed: the command probe, HTTP probe, and the TCP probe. So the kubectl is a mechanism through which we are applying our manifest to the Kubernetes. After that, the handler will take care from there that I want to apply it or not. I want to use this health check handler or not. So kubectl is for just applying the manifest and creation of resources. After that, the Kubernetes is responsible to make this health check handler to work upon. Does that answer the question? Yeah. Okay, cool. Okay, I guess I have answered pretty much every question. Okay. Now let's try to do a little bit of hands-on. So here I have created one lab of the probes lab in which you have a problem statement. So what we are going to do in this lab, we are going to deploy an Elasticsearch, and we are going to create an Elasticsearch service as well. And then we have this application called salary, and this application is actually dependent on the Elasticsearch. So for example, if this application is able to make the connection to the Elasticsearch, it will become ready. Otherwise, it will not become ready. So here we are going to make a, you can say, liveness test. So in the liveness test, I have said that if I'm not getting a response in the 10 seconds, that means this application should get failed. So what we will do, we will set a delay time for this application, that this application will not respond in, will respond in 100 seconds. And we have defined the timeout seconds as a 10 seconds. So ideally, this liveness probe will fail again and again, and the readiness probe will also fail. So this application will not come up. So let's try to create this thing inside the Kubernetes. So I'm going on terminal. Let me know if you guys are able to see my terminal, or you are able to see my Chrome only. Okay, you guys are only able to see my Chrome. Let me share the complete screen then. Yeah, I hope you guys are able to see it now. Okay, awesome. So what I will do, I will go to the temp directory. Here I will say probe lab. This probe lab, I'll create one file called Elasticsearch, in which we are simply deploying an Elasticsearch inside the Kubernetes cluster. So here I have pasted a deployment. Inside this deployment, I'm just defining the method information, and I'm saying that I want to run a one replica, and my container definition is this, where I want to run this Elasticsearch image on 9200 port. That's it. After that, we need a service as well to communicate with this Elasticsearch. So we will define this as well. And let's try to create this thing first inside the cluster. So I will create a namespace called probe lab. And inside this, I will simply apply this Elasticsearch. Definition. Now let's see if the pod is healthy or not. Let's wait to become it ready and in the running state. Yep, it's in the running state. Now we will deploy the salary application. Inside the salary application, we have defined two things. One is the readiness probe, and second is the liveness probe. So inside this readiness probe, I'm saying I want to make a connection on on salary health URL on 8082 port, and the initial delay seconds is the 10 second. Before making for the first probe, it will wait for 10 seconds, and after that, every 5 seconds it will make request to this URL on 8082 port, and it only need one success threshold to pass, and the timeout second is 10 seconds. So for example, if it is not getting a response inside 10 seconds, it will fail this probe and the container will be restarted. The same definition has been defined here as well. So in the liveness probe as well, we are using the HTTP GET method, where I am saying that I want to make a request on salary health URL on port 8082. And for the first liveness probe connection, it should wait for the 10 seconds, and after that, it will make a request to this URL. And after that, it will make consecutive liveness health check at every 5 seconds with a success threshold 1. So it will get only one success threshold. That means it will say the liveness probe is passed. And after that, it will wait. It will again go after the 5 seconds. And the timeout seconds is again 10 seconds. So the definition has been defined. Now we will simply try to create this inside the Kubernetes cluster. So we will say I have a salary.yml file. And inside this salary.yml file, I will make a connection probe. Now, if I do string of pod, so this is in the container creating state. Let's wait in the running. So if you see, it's 0 out of 1 ready. That means it's making a health check. So if I describe this pod, so the container has been started. And if you see the readiness and liveness definition, it's there. We have defined here. Now, if you see here, this pod is the running state. Now, if I go inside this particular pod, let me show you how the health check is working here. Okay, I think this is an Alpine image. You have call? Okay, I have call. So basically, I'll try to make it on this application. So I will say I will make a request on HTTP localhost 8082 on /salary health. You can see the Elasticsearch is running, right? And the status code is 200. You guys can see this, right? Now let's try to do one thing. Let's try to make a delay here. So what I will do, I will make a delay of 100 seconds. That means this response will come into the 100 seconds and see what is the behavior of it. So I'll make a request of this. Now, if you see here, if I make this request, it will be delayed by 100 seconds. I'm not getting a response here. Now let's go here and see what is the behavior of the salary application. Did you guys see this? One restart count, 0 out of 1 ready. So let me describe this as well now. This will be quite interesting. And we have described this. You guys can check this. Will be restarted. So now I guess you guys have the clarity what exactly Readiness Probe is doing here and what exactly the Liveness Probe is doing here. Does this make sense, guys? Okay, please show the OP again. I did not get Viraj what exactly you mean. Okay, describe output. Okay, you want me to describe the output again? Yeah, sure. The code base is same, Honyank, but I have made a request in this application to delay the response by 100 seconds. That's why it's restarting. The code base is similar. I just modified the application to give a response in 100 seconds and the timeout second is 10 seconds. So it is not getting the response in the 10 seconds. That's why it's restarting. Does that make sense, Honyank? Yep, awesome. Okay, any other question or I have few more things to show you guys. I can move ahead then. Okay, I think guys. Okay. Now the importance of probes inside the deployment we are going to talk about. Let's suppose this is a deployment inside the Kubernetes and there's a version 1 is running here. Inside the version 1 I have 2 pods in the running state. Now in the version 1 what is happening here, the traffic is being sent to this v1 pods. Let me show this. Yeah, this pod. Now we have deployed a v2 version of code. Now it is in the initialization phase. In the initialization phase, when it is ready, then only the traffic is being sent to it. Let's suppose what will happen if we are not defining the liveness and the readiness probe. Version 1 was running fine. You guys were aware of it. You have deployed the version 2 of code. Now the version 2 of code is not somehow is not working and it is not able to connect with the database. But the liveness and the readiness probe is not defined. That's why it's becoming in the ready state. What will happen and what could be the consequences of it? Anyone? The request will start failing because the v2 does not have any liveness and readiness. We have simply deployed it and we are believing in on our guts that it will work. But there's no health check mechanism defined there which can check the version 2 which we have defined if it is working fine or not. Yes, the traffic of v2 will fail because of the traffic of v2 is not have any health checks. The liveness and readiness probe, the traffic will only shift to the v2 and after that it will start failing again and we have to again roll back to the v1 version. But ideally, what should happen here? Ideally, there should be a service which is serving the traffic and these are the v1 pods. Now what we are trying to do, I want to make a deployment on v2 version where I'm verifying that if the readiness and liveness probe is being succeed. So first, what will happen? A v2 pod will be created. This v2 pod will not receive the traffic unless and until the readiness and liveness probe is successful. So let's suppose the readiness probe is successful. What will happen? It will start sending the traffic to this pod and it will delete the one pod from here. After that, it will create another pod, the v2 pod. Again, it will wait for it for the readiness to be passed. And once the readiness is passed, it will start sending the traffic to this pod as well. And it will delete the old one. So once the readiness and readiness has been passed for v2, then only it should receive the traffic. Otherwise, what will be the state? Otherwise, this will be the state for the constant deployment. The v1 has been already readiness passed, so that's why it's running fine. But somehow, let's suppose v2 does not have any readiness probe passed. V2 has defined the readiness probe and the readiness probe is failing continuously. So it will be in the creation state, it will be in the running state, but the service will not send the traffic to it unless until it is becoming in the ready state, like this. You can see, I think it's, I have removed it, but if I go to the one, yeah, this one, it was 0 out of 1. That means it was running, but it was not ready. So unless and until my liveness, my readiness probe is not being passed, this ready state will not be achieved and the service will not send the traffic to that application. So this will be the continuous state if the V2 readiness probe is not being passed. Once the V2 readiness probe is passed, this will be the state. The service endpoint will connect to the V2 and it will remove the traffic from V1. And then again, this will happen for the second V2 pod. If the readiness probe is passed for the second V2 pod as well, it will remove the traffic from old V1 version of the application. Yes, Prashant, you are correct. The KTS simply assume that our pods are up if it is in the ready state. So to define the readiness of the state, we should always define the readiness probe inside the application. Now, I have one demo to show you guys for this deployment related stuff as well. One second. So I'll simply go with this particular part. And at this particular part, let's suppose I have this application called attendance, and this does not have any readiness and liveness probe. Let's simply try to deploy this application. So what I will do, I will go here. I will create an attendance.yml and yeah, 1 second. Let me exit this thing first. Okay. Now here I will simply say attendance in the now if I do kubectl get pods -n probe lab, the container image is being pulled. Now if you see, this is created, but let me describe it. Sorry, the probe lab. If you see here, the container has been started, but there is no indication that the readiness or liveness is being passed, and there is no sign of readiness and liveness inside the container definition as well. Now let's try to deploy the second version of code, 2.0. And whatever the definition which I have defined, I will say it B2. And then we will give a watch condition. Now, if you see here, oh, sorry. It's in the running state. It has terminated the previous one. But how are you ensuring that the second version of code which you have deployed, it is running fine or not? It could be like the second version of code is not running, but still it has terminated the previous one and make the live the new one. So this is the second version of code, but we haven't defined any kind of check through which we can validate the second version is sane and it is running fine. So if I actually check the functionality of this application will not pass it. Let's suppose if I go to this application, sorry, my bad. It's again the Alpine image. And here we have the 8081 port. So I will simply make a curl request on HTTP localhost 8081/attendance health. You guys can see the request type is 400 and the MySQL is not yet up. But the container state, it's running. And the ready state is also ready. Did you guys got it? What exactly I'm trying to show you? The application is not actually connecting with the database, but somehow it is showing it as ready. So whenever I'm doing a deployment, I'm not sure that if that application is going to work or not. Is it clear, for you guys? Okay, awesome. Now let's try to do the same thing using the probe. Similarly, we have defined 8081 port on /attendance health. The initial seconds is 3 seconds, the period seconds is 3 seconds, and the success threshold is 1, and the timeout second is 10 seconds. Now let's try to deploy this application and see what happens. So I will say attendance probe.yml, and I will simply deploy this application in the probe lab. Can you please describe the pod? What is this showing here? I already described beneath. If you see here, it was in the running state. Because the liveness is not defined, so it does not have anything to check. Now I think you should see it, because this will make a lot more sense. Now you can see it has been restarted and it is not in the running state. If I describe this pod now, the readiness probe is also failed. You guys can see it. The status score is 400. Right? You guys can see it. Hello? Oh, okay, you guys can see it, right? Okay, now you guys can see it, and it is not passing because the status code is actually 400 and MySQL is not up. Now let's try to do one interesting thing. Let's try to deploy MySQL again. Right now it does not have MySQL, but what if I deploy a MySQL here with a service? Now let's try to deploy MySQL inside the probe lab. Now if I go here, it's in the creation state. Let's wait it to get created. Okay, so DB is running now. Now let's see what is the behavior of this one. Now, right now it's in the crash loop back off state because it has been restarted multiple times. But let's see what behavior now it will show. Now you can see it is in the running state. And you will also see this will become ready now, because the dependent application is up now, the database. Okay, I think still trying to make a connection to it. Let's wait for 1 more minute. It should restart automatically. Okay, I'll check that once this container is ready, because if I go to that particular part, this will be missed. I'll check that, Gopal, don't worry. See, once it is restarted again, it's in the crash loop back off state for maybe run the get pods again. No, I have made it on the watch state, so it will work. Right now it's in the crash loop back state. Again, it will go into the running state. It should succeed. Now it's again in the running state. Okay, it's failing again. Let me go inside the pod and check if the state is fine or not. So I'll simply say command C, command V, shell probe lab. Let's try to make the connection. Okay, it's not up yet. Let me check why it is not up yet. VPC const.d. I think the okay config.yml. The MySQL is not up yet. Let me check, guys, once again. The DB should be up now. svc-n probe lab. And I think it should be a headless service. I think somehow this become a normal cluster IP service. Ideally, it should be headless service because it's a TCP based application. So I'll try to delete it again and let me create it again. So I will simply delete the MySQL again in the probe lab. And if I go to the MySQL lab, I just have to do one thing. I have to make the cluster IP equals to none. Let's see what happens now. So let's go to the pod state again, the container creating. Okay, DB is running now. Now let's go to the attendance pod again. SQL connection is not up yet. URL is right. So what is wrong? One second. Let's try to see what exactly the issue is. Let's go to the database. empmsdb bash -n probe lab. Go here. We will execute the same credentials. MySQL -h port equals to 3306. User is root, and we have to put the password. Password is password. Okay. Okay, we can able to connect to it. Okay, so database is not created here. My bad. So we will simply say create database attendance DB. Now the database is created. Let's try to go again inside this application, and you guys can see this. The status code is now 200. Yeah, this proves that. But we haven't defined this thing for the MySQL one. But I guess this little debugging actually helped, right, guys? So now you guys can see this, what exactly was happening here. So now if I go to the get pods again, this is in the crash loopback state. After some time, this will also become red. That is something when we create a data TCP based application, we should always keep the cluster IP in bus away, sir. The reason is it's a headless service, and by default that the Kubernetes creates a layer 7 based service which distribute the traffic. So we cannot manage the layer 4 based application using the layer 7. So ideally, whenever we are creating a database kind of thing, we should always use the cluster IP equals to none. It's ideally a best practice, we can say. Now we can wait. This will also become ready now. I'm damn sure. Just give it like a minute. When it was failing for the first time, it took 1 minute, which is more than a timeout value. No, it has been failed yet. The crash loop back actually works in the incremental, Gopalakrishnan. So for example, if it is after one restart, it will increase the time so that it will not impact the system much. So for example, first it will restart it 10 seconds, then it will give it 20, 30. So it's an incremental journey, just like you have a Gmail. Inside that Gmail, if your internet connection is not working, it says I'm connecting in 5 seconds. Then it says like I'm connecting in 10 seconds. I'm connecting in 20 seconds. So that's the same kind of thing. Can we these probes give exact problem? It can. So basically, if you see here, my application was giving a 400 status code. So it was giving the right kind of thing. Yeah, you can have that. For example, if you are defining command probe, Bashiveswar, in that case, it will simply say that database does not exist. So the command probe actually gives the shell command error output while describing it. So if you have defined a command probe where you are checking the database, and if it is giving one exit code as a 1, the command probe will print that this is why the command probe has been failed. But in the HTTP probe, it was checking the status code. So that it makes sense. It was giving like, I'm just getting a 400 status code. That's it. Okay. It's taking a lot of time to be restarted. Let me check. Now it will again restart it. Just give it a minute more. Actually, I can make it directly work if I delete this. So I should use the command probe. Depends on the scenario, Basaveswar. For example, if you are using a middleware based service where the checking the port is not sufficient, there you can use the command probe. For example, here we can have more advanced health check if we have defined a command probe, and there will be we will be checking if that database exists or not. Does that answer your question, Basaveswar? No, you can define a single probe right now, Basaveswar. You cannot define multiple probes. But if you have that kind of scenario, you can define a command probe, and in that command probe, you can write the shell logic for multiple kind of health checks. Yep. Awesome. Let me make it ready by simply deleting it. It will take a lot of time to again crash loop back to start because the incremental time is right now too high. So I will simply delete this pod and let's see what happens. So now it is creating it again. Now, if you see, this is ready. Now, if I describe this pod now, let's see what exactly we are getting here. So the liveness probe is this. The readiness probe is this. And it has passed the liveness probe and the readiness probe. That's why this pod has become healthy. If I delete the database from here, this pod again will get restarted. Because if I go inside this, and after that, if I simply execute the curl command to check the health of it, so I will say curl -v http localhost 8081/attendance/health. MySQL is running, the status is up, and the status code is 200. That's why it's working. Is there going to be crash loop back time to lesser or a constant value? Yes, in the deployment, you have that option in Gopalakrishna, where you can define that what should be your termination grace policy. There, on the basis of that, you can define it. Awesome. So now I'll hand it over to WizLab guys to give a quick tour of WizLabs by Abhishek Maurya. Sneha, Abhishek, over to you guys.
Hi everyone. My name is Abhishek. I'll be presenting the WizLabs demo to tell you all everything about what WizLabs does, what are the things that we get when you purchase something from WizLabs. So to get started, I would just like to share a small PPT with you. But before that, can I have a quick yes if you can see me properly and see the screen?
Yes, Abhishek, we can see.
Perfect. Thank you for the confirmation. Okay. So what WizLabs are trying to build out of the platform is currently we are just having online courses and practice tests for your certification exams. But as you see, Abhishek Dubey has performed a really nice demo of how Kubernetes and other practices should work on. So here we'll be understanding what WizLabs is doing in alignment with the hands-on thing. Then we will see what are the cloud certifications that are available. Maybe with AWS, I can show you all Azure and Google Cloud. Then we will discuss the labs features that is available with WizLabs platform. And then if you have any questions or queries, you can put in the chat or Q&A section. Okay, so building a hands-on experience in live environment is just means that you not just learn the theoretical part, you should also practice the demo session that is done. So how to install a particular thing, how to create some stuff in AWS console, you will get a chance to do so things. So WizLabs guides you at every platform, at every step. We have two sections for the labs. So first one called as lab details. This is where you are going to see the brief description of the lab, that what it does, what are the services that are used, what all those services talk about, what is the architecture diagram, how does this works with multiple services having collaboration with, and then the individual steps in details. So what all things you need to do, where you need to click the right steps on it. And also to guide you more with that, we have got the screenshots of AWS console and also the required commands and code if required. Okay. Once you have done everything correctly, then you have a validate button where you can just click on the validate button and it will tell you whether you have done it in the correct way or not. Now, each resource that you create, let's say, for example, you are creating an EKS cluster. The EKS cluster has been created. It is in up and running state. What is the current version of it? Everything will be verified and validated. Okay. And if the lab outcome is not as expected and you might have missed something or diverted from the steps, we will give you the steps to fix this in the next attempt. Now also you can submit your feedback to let us know if we can improve something. Now, one of the very the problematic thing with trying out this hands-on is setting up your cloud environment, setting up your infra, doing everything from your side on your own. The second thing is when you want to create this AWS accounts or Azure account, you need to provide your credit card information. And these things are having risky because what if I create a Kubernetes cluster, launch multiple pods, there will be so many EC2 instances running up of multiple instance size, and that can charge me so much, right? So to do avoid that and to make the cloud computing learning as a risk-free, WizLabs has came up with hands-on lab and lab challenges, okay, which does the account setup in no time. You just click on the open console button. I'll just show you a quick demo on how those things work. But you don't have to worry about setting up your account or environment. And WizLabs guides you on every step. So this is just a demo of how the platform look like. Let's go into the platform and see how that looks like. So I'll just go to the wizlab.com to access the hands-on lab. You have to make sure that you are using a laptop or desktop, and you can just log in yourself. So once you log in, you will be landing on this home page. Then you can go to my courses section. And inside that, you will have multiple courses that you might have purchased, or if you are a premium user, then you will have access to all the courses that are present. So in the some of the AWS courses, I have been enrolled and they are currently in progress. So I'll just maybe start with AWS Certified Developer Associate exam. And here you can see we have 21 practice tests that we give with WizLabs and also 128 video. So all these two things needs to be purchased separately. The thing that comes up handy and free for you is the labs. And currently we do have 85 labs available for AWS Certified Developer Associate. So you can see all the labs are listed. You can just click on the start for anyone. So I just search for EKS, and currently on EKS we have got two labs. One is create a cluster and install kubectl. This is just a basic lab guides you how you can create a cluster and install the kubectl. So let's click on the start button. And as you click on the start button, you will be diverted from vizlabs.com to play.vizlabs.com, which is your environment to do the hands-on stuff. And as you can see here, we have got lab details. We have got introduction where it tells what is Amazon EKS. This is the small architecture diagram, what you will be doing, how you will be using the EKS cluster to connect it with AWS Cloud Shell, and then all the task details. So the first task details is launching the lab environment, creating the EKS cluster, creating the environment in Cloud Shell, and so on. So the very first task says that launch the environment by clicking on the Start Lab button. So we have got a Start Lab button. You can just click on the Start Lab button. This will take 10 to 15 seconds. In the meantime, you will get a fresh AWS account from VizLabs, and yeah, you can see the environment is ready. The next task is to just click on the Open Console button, and this will give you access to AWS Management Console. So I have just clicked on the Open Console button, and this is now opening in a new tab. And what I have to do, copy the IAM username and paste it here, and also copy the password. Okay, so I think it's not copied. Let me copy again. Paste it in the IAM user name section and copy the password and put it here. For few of the labs, we are giving access to AWS access key and secret access key, where you need to do configuration with your CLI and for SDK. So at that time, you can use that. Okay. So now we are into AWS Management Console, and you can see it's just so easy to use the platform. Now the next step is you can create a EKS cluster, and you can just simply go to the getting started page and do your task. Okay, so I'll not be performing after this. You can just try out all those things, and if you are a VizLabs user, you will have the access to labs, and if you are not, then also we have a solution for you. You can participate in the quiz that we will have right after this session, and you can win a practice test or online course of your choice. Okay, so now I'm gonna end the lab and just tell you how the VizLab courses and certifications are aligned. So now I'm on the Amazon AWS Cloud certification page, where I have all the certifications listed. They basically are into different categories. First is foundational, then associate, professional, and specialty level. And VizLabs has courses and hands-on lab practice test for all of the labs, all of the AWS certifications. Okay, similarly, it goes for Azure and Google Cloud also. Okay, so now we have a, okay, I forgot to miss to show you the validate button, but once you create those stuff, the validation will say like you have done all those things, and if you have not done, the validation will simply fail. Okay, so if you have any queries, you can ask me in the chat window. Thank you. Over to you, Abhishek.
Yes, thank you so much, Abhishek, for this great demo. And I think we have one question from Suman. He's asking, I have used for AWS. Do you have the similar in GCP? Would you like to answer that, Abhishek?
Yes, we do have created the hands-on lab and challenges for GCP also. You can check it out on your course section.
Okay, thank you, Abhishek. Yes, so now it's time for the quiz, which we have specially crafted for you people, and there will be special rewards for 5 people who answer the quiz correctly. I would request Mayank to share the PPT. Yes. Okay, great. So before going ahead with the questions, I would like to tell you what are the rewards we have for all of you. So there will be 5 questions, and we will announce 5 winners. And you have to answer for each question in the Q&A section, not in the chat box. So you can see there is a Q&A section at the footer of your Zoom screen. And there is a particular format you have to follow in order to answer your questions. So for example, if the answer to question 1 is option A, then you write it like this, 1A. For question 2, if the answer is option B, then you write 2B, so that we know which question you have answered for. Okay, accordingly, we will be choosing the winners. Now, when it comes to awards, Mayank, can you go to the next slide, please? Yes. So 5 winners who will be announced out of this quiz, they will be rewarded with free WizLabs course or practice test of their choice. And then we also have some special discount codes for all our attendees. So you can, if you are interested in buying a course, as Abhishek mentioned in his WizLabs demo part, that you get access to free hands-on labs if you have any online course or practice test with you. So we have a 60% discount over that, and you can use the code that is there on your screens. Then we also have a 35% off on WizLabs premium subscription plans. Right now, we have also launched monthly plans. So if you are interested in buying just 1 month or just 3-month subscription, you can do that as well. So you have the code for that also on your screens. Okay, so these are the rewards. Now, keeping that in mind, I would request you all to do an active participation in the quiz. Okay, over to you, Abhishek. Abhishek Dubey.
Thanks, Neha. Let me share my screen. Maybe we can go with the quiz then.
I think Mayank can share the quiz.
Okay, Mayank can share the quiz. That's great. Mayank, can you? Yeah. Okay, so the first question is, which probe we generally use to check if the container or application is ready to serve the request? The option is the Readiness Probe. The option B is the Liveness Probe. So you guys can answer that. Answer these questions. Okay. Okay, I think we can move to the next question, Mayank. Can you please move to the next slide? Okay, can we pass custom headers in HTTP handler of probes? Whether it is a Readiness Probe or Liveness Probe, can we pass custom headers to it? Okay, people are answering this. That's great. I think we can move to the next slide, Mayank. Okay, if we are running a MySQL as an application inside the Kubernetes, what type of probe handler we can use? We can use TCP command or both. Okay. Yeah, Mike. If Liveness Probe is failing, can we define a custom action policy? That means, can we define a custom action policy in sense I don't want to restart a container, I want to do something else. Can we do that? Okay. Okay. Is Readiness and Liveness Probe to handle the deployment? Is important to handle the deployment of new version of code? Okay. I think these are all the questions we have. And thank you guys. Thank you for being with us.
Sorry, Abhishek, would you like to tell the correct answers before we?
Sure. Can you go back to the question number 1? Awesome. So which probe we generally use to check if the container or application is ready to serve the request? So the answer is Readiness Probe, because the Readiness Probe is actually check if the new container which is coming up is ready to serve the request or not. The Liveness Probe is more about to check that if the application is live to serve the request or not. If it is, once the Readiness Probe is passed, Liveness Probe takes over from there and check if that application is live and responding. But to check for the first time if the application is being deployed inside the Kubernetes cluster, if it is ready to serve the request or not, the answer is Readiness Probe for that. The question 2, can we pass a custom header in HTTP handlers of probes? Yes, definitely we can. I think one of the slides I have already demoed it. So when we are talking about the HTTP handler, we were discussing about the port URLs. There we also discuss about the custom headers as well, where we can pass custom headers for it. So for example, if your application has an authentication mechanism, and in that authentication mechanism, you have to pass authorization bearer token inside the header. In that kind of scenario, you can leverage that. So yes, we have that functionality. If we are running MySQL as an application inside the Kubernetes, what type of probe handler we can use? You can use TCP and command both. It generally depends how do you want to use it. So for example, if the database port connectivity is sufficient for you, you can use the TCP, but let's suppose you want to go to the next level, you want to check if the database tables and the queries are executing fine, you can go with the command as well. So that's why the answer is both. Fourth question, if Liveness Probe is failing, can we define a custom action policy? No, there is only one action policy. The container will be restarted. We cannot define any kind of custom policy while Liveness or Readiness Probe is failing. The question number 5 is, readiness or liveness important to handle the deployment of new version of code? The answer is definitely yes, because we have already seen it. If you are deploying the new version of code and if the readiness and liveness is not there, it will become ready and the client and the customer request will start failing because we haven't made any kind of health check to it. So it always makes sense to implement the readiness and liveness inside the deployment. So whenever we deploy, the deployment will always make sure that the application is up or not. And now we can say thank you for being with us.
Yes, thank you so much, Abhishek. And I think this was really an informative session. And I'm really hopeful that our attendees got to learn a lot from you today. And yes, thank you so much for agreeing for this session. And yes, now it's time for our last, I would say, tradition of the WizLabs webinars, which is the group picture. So I would like to see all the attendees who have joined us today, and you all can raise your hand who want to be a part of this picture, and we will promote you to panelists so that you can switch on your cameras.
In the meantime, you guys have any feedback, you can write in the chat as well regarding the session or anything, please.
Yes, we would love to know that.
We would love to know that.
Those who have joined us as panelists, you can switch on your cameras. Hello, Sridhar. Hi, nice to see you. We'll add a couple more people.
Okay, Nurul is also, Vineet is there.
Okay, we have an amazing feedback from Yash in the chat box. Congratulations, Abhishek.
Thank you, Yash.
Okay, anyone else would like to be in the frame, or we can continue then? Okay, great. Hello, Nurul. Hello, Vineet. Hi, Suman. Nice to see you. Okay, great. So we'll click this picture. I hope you all are ready with your poses. Just a minute. Yes. Thank you so much for being here. It was nice having you all. And you can join us for our upcoming webinars. All the details you can find on our social media. And yes, this picture also you can find on our social media very soon. Thank you so much, everyone.
Yeah, Vasaveswar, we will plan for that in future.
Yes, we'll surely plan that.
Okay, thank you so much, guys. Thanks for joining.
Yes, if you have any other feedback, you can surely connect with us, and you can connect with Abhishek over his LinkedIn also. So feel free to do that.
Thank you.